Okay. I was going to say that it was the last time I gave a talk here, but I think it was before then. But I gave a talk about SceneKit last year. And at the end of it, I got a question of how SceneKit compared against more traditional game engines like Unity and Unreal. And the question at the time was that it was more like comparing apples and oranges, and that SceneKit wasn't really a game engine. And it still isn't. Because the way that Apple decided to do this at WWDC is to keep both SpriteKit and SceneKit focused on pure rendering, and instead have other frameworks that work together with them. And new this year is GameplayKit, that is strictly for gameplay. And it works with both SpriteKit and SceneKit and takes care of many of the gameplay related tasks, such as AI. And that is the what and why of GameplayKit. GameplayKit contains a lot of small pieces that you can use a couple of. You probably won't use all of them, depending on your game. But each piece is very small, and they're also made to work well together. SceneKit is also a very opinionated framework. So it tries to follow what actually is the best practices of games programming, using a lot of composition-based design patterns. It enforces strict state machines, which means that it doesn't want you to write the giant switch statement of doom in your games. It wants you to create separate states and define which states you can transition from, etc. Agents, goals, entries, and components are also very opinionated APIs. But hopefully you will see that they make sense in a gaming environment. Let's start with the probably least exciting, random generation. It's a big component in games because it would be very boring if it was the exact same every time. And why would you need random number generation? You have arc4rand, right? Well, random number generation for games need other types of properties from the number generator. It needs to be deterministic, so that if you're having a multiplayer game of some sort, it doesn't have to be real time. It could be like a card game or a puzzle game of some sorts. You want to make sure that both ends generate the same number. You also want the generators to be independent, so that if you have multiple sources within your game engine that generates random numbers, they should never affect each other. So that generating a random hair color should not affect the power of your weapon. And you want to know that the distribution, so that you can have good, reliable gameplay. And SceneKit offers a lot of different distributions and convenience methods to generate random numbers from them. It's not the most exciting thing. It's a fairly simple API. But yep. Oh, sorry. Yes, I'm very used to talking about SceneKit. GameplayKit. And if I ever say SceneKit again, it probably means I probably meant to say GameplayKit. Another part of GameplayKit, see, I'm having real difficulty with that, is entities and components. And what entities and components are, it's a composition-based design pattern for functionality. So an entity is a game object, like a player or something that you can interact with, and a component is a piece of isolated functionality. So instead of having a hierarchy of classes that inherit from each other and get their behavior that way, you create behaviors in each component, and then you add components to well, a collection of components for each entity. It is very strict about this, so I say that it encourages / enforces this component-based design. It also plays well together with some of the other design patterns that you will see later. It uses this through another very common pattern in game engines, which is that you have an update loop that runs every frame. So both the components and the entities have an update method. If you call update on an entity, it will update all of its components with the current time. Similarly, you can create a component system where you can add components to. So if you, for example, you have a movement component for everything that can move, and you want the movement to happen before anything else, then you can add all of your movement components to the movement component system. You can update it first and update everything else later. Another well-known design pattern is the state pattern, most commonly used in the state machine. GameplayKit has a couple of classes for this. It makes it very explicit, where you create your states and you add them to a state machine, and they define which states they can transition to. And also, when you transition to a state, if you try and transition to a state that you can't transition to, it will fail. And when you transition to a state, the state you're transitioning from will be notified that you're leaving it, and the other one will be notified that you are entering it. It allows you to separate your code into each state so that character or an enemy in your game that can be in several different states can have their logic for the different states in the specific state classes. They also play in with the update mechanisms, so that if there is updates that need to happen within the state, that plays along with the entities and components. A slightly more interesting part of GameplayKit is the min-max AI. And min-max is a simple but powerful algorithm, you could say, for picking up the optimal movement. It relies upon the score of the game at a current point, and by knowing all of the possible actions that could be taken, and then scoring them, and then doing all possible actions that could come from them, and scoring them, it can figure out what the optimal move is. To be able to do this, it needs 3 pieces that are protocols. It needs the game model, and the game model is the state of the game at a point in time. And the game model has 2 things that it can do. It lists all possible updates, and it can also perform one of those updates. The second thing that it needs is a player, and it needs to know which player is doing which move, because it is trying to optimize for its own player, but it's also trying to do the optimal moves for the other players to figure out which potential moves to avoid. The last piece that it needs, also protocol, is the update. And the update is a move that the player can do. So with these 3 things together, it starts off in the current state, asks for all of the potential moves that the player can do, and then for each of those, it applies the state, gets into a new state, and then it switches player. And then it tries to do the optimal move for the player, switches back to the next player, tries to do the optimal move, and creates this tree. And the name min-max comes from trying to do the thing that is optimal for the player itself, but the least optimal for other players. So maximize the the player that it is simulating and minimize the others. This means that it needs to run in a turn-based type of environment where there are distinct states. It doesn't have to be a multiplayer game. You could use it to simulate a single-player game as well, and use it to suggest more actions for the player. Because it relies on knowing far in advance what's going to happen, it works best if there is no randomness in the game and that all information is available to you. So for example, in a card-playing game where you don't know what cards the other person is having on their hand, you can't really predict what they're going to do. And that makes it slightly harder for the AI to figure out what the best move will be. It also depends very heavily on your ability to put a score on the status of the game model. So if you, for example, take a chess game and you score the current situation as the number of pieces that you have, that's a fairly poor score because some pieces are worth more than others. So the AI wouldn't know that it's more okay to lose a pawn than it would be to lose a knight or a rook. And it uses this score to optimize. So it very, very heavily depends, more heavily on your ability to score than the randomness and the available information in the game. And most of it runs by itself, except you have to do the difficult part of scoring the game. Wow, nice colors. Another interesting part of GameplayKit that's very, very fun to play with is pathfinding, something that has been lacking from SpriteKit and now is very, very easy to integrate. There are two different ways of pathfinding. One is where you are avoiding obstacles, so you can move freely within an area, except for certain areas. So it's a free movement. The other one is fixed to an integer grid. And if there's obstacles in the integer grid, then you would leave out points in the grid. The pathfinding in itself, as a separate component, only finds the shortest path through this graph of points, but it doesn't do anything else with it. Oh yes. For that, there is another part of GameplayKit that is called agents. And an agent it can be an entity in your game, but you should more think of an agent is an abstraction around physical movement. It is goal-based, so an agent in GameplayKit has many different goals that it wants to satisfy as best as possible. And there are also restrictions to how fast it can move, how fast it can turn, how fast it can brake and accelerate. Given these types of goals, you can tell it that you want to follow a path. But if you are configured to be very, very poor at turning and the path has a very, very sharp turn, then it might have to slow down or it might have to take a large curve, depending on how you configure it. You can also tell it to avoid obstacles so that it will not crash straight into them, but take a tour around them. But it's strictly for movement, and it integrates very well with SpriteKit, where you can get the obstacles from the physics bodies of the SpriteKit scene, and then you can get the path, and then you can tell one of your sprites to be connected to an agent, and the position of the agent would be the position of the sprite, and then you just update the agent on every render loop. So that's yet another piece that ties into this update mechanism. And agent entities and the state machine, they work very well together hand in hand in the sense that you can have a movement component for all of your little NPCs in your game. And as part of that movement component, you figure out where they want to go. And then based on an agent, you update their position and re-render them using another component, like a render component, which renders a sprite. The last piece of GameplayKit is rule systems. So it's for the decision-making of these little NPCs in a game. And it takes a set of rules that are predicates and the state of the game, which you describe by setting properties in a dictionary or setting values in a dictionary. Then by evaluating the rules against the current state, it comes out with a set of facts. These facts can either be completely true or completely false, but you can also have fuzzy rules that allow for facts to be sort of-ish, maybe true. A value from 0 to 1. And by just defining the predicates and just setting the state, you get the weighted facts. The tricky part then comes to making a decision out of these facts. If it's true or false facts, then it's usually very simple. You get the ones that are true, and based on their actions, maybe you switch the state of one of your entities, and that in turn changes something, goes into its own set of logic. Otherwise, based on if you only have fuzzy rules, or if you have rules that can apply, you can have both a rule that is true, but you can also have a fuzzy rule that plays in with it. You have to weigh it somehow and figure out the one action that you want to do next. And there's no real one way of doing it. It's what's up to your game. So that's another part of those. You just have to figure out what works for you, and it might be tricky, just as scoring a board game here based on a fact, which could be there is a nearby enemy. Maybe that means that you should move towards it. But you might also have a rule which says that enemy is more powerful than me. Maybe that rule should trump, and the conclusion should still be that you should flee. I don't really know how I am on time, but I don't have that much more to say, actually, other than that there is actually very, very good sample code this year. There are multiple projects. GameplayKit, SpriteKit, and SceneKit works across Mac and iOS. GameplayKit is iOS 9 and El Capitan only. Integration with SpriteKit is a lot better than it is with SceneKit, because 2D is a lot easier to map into these realms of problems. But there's both good sample code, there's a very good programming guide, and quite up-to-date documentation for most of it. Questions?